Good day. I am John Patrick Estelane and I'm here to discuss about Secant Method in C++. So before we start, I would like to acknowledge some key persons in helping me understand the Secant Method and understanding the C++ behind it. So I would like to thank Engineer Jack from YouTube, which he explained the brief explanation of the Secant Method and with some C++ algorithms. There are also two websites that I was able to access in reaching out for some basic um, functions of C++. And also the website where I downloaded the video editor I'm using right now, and a YouTube video of a secant method tutorial. So let's start. So secant method, although the bisection method always converges, so the speed of convergence is usually too slow for general use. So secant method is here to speed up the process of convergence. Secant method is an improvement of the bisection method and is also applicable to both polynomials and transcendental functions. So next, according to Google, secant method is a root finding procedure in numerical analysis that uses a series of roots of secant lines to better approximate a root of function f of x. So we are not going to discuss how we arrive on this formula, but these are the key formulas that we are going to use in finding the x sub 2 by using the secant method. So as an example, we are going to use the function that we used during our video lectures. X cubed minus 4x squared plus x minus 10. Before discussing the algorithms of this C++, I would like to have a sample of the program. So at first, the title, Secant Method Calculator using C++ by John Patrick Estalane. So first, we are going to enter the degree of function from 3 to 10. So I designed this C++ program from the degree of 3 up to 10. So let us try the sample, which is x cubed. So we're going to use 3. Then for a 3 is 1, negative 4, 1, and negative 10. Precision, we're going to use for decimal places. And let's use an error of 0.001. Initial values will be 4 and 5. So um, comparing it to our visual lectures, this is the table that we're always using. So there's the iteration number, the x sub 0, which is the initial value of x, the x sub 1, x sub 2, f of x of 0, f of x of 1, f of x of 2, and the error of each iteration. So we've reached the fifth iteration, satisfying the condition of error of 0.0001. So this after 5 iterations, therefore after 5 iterations, the root x2 is 4.3069. So I also created an Excel program using secant method, and I'm going to use it as an to verify the answers. So this is the Excel formula that I was able to to create to verify my answer. So let's go back to the C++. So the roots will be, since it's x cubed, we are going to use 1 here, 1, then -4, 1, and the constant -10. As you can see, when you input the values, the coefficients of each um, degree of x, there will be a function here, x cubed minus 4x squared plus x minus 10. So this is the values of different value of x and its corresponding f of x. So we choose the value of x as 4 and 5. Since we're going secant method, I'm going to use this table. So first, let's input the 4 and input the 5. So here, as you can see, we've only used 2 iterations. These 2 iterations, two. So I'm sorry, we used 5 iterations in arriving with the answer 4.3069, which is the same here in 4.3069. 5 iterations. And I also arrived in my Excel program 5 iterations, satisfying the 0.001 accuracy of error. Going back to the C++ algorithm, this one. So these are the functions that I will be going to use. Some of it I don't understand, but this was included in the videos I have watched. Okay, let's start. So at first I put the header of my program. Then here it says enter the graph function from 3 to 10. So I just limit my function to be from 3 to 10th degree of function. So these are the scenarios. If you exceed the degree of 10 here, the answer will be the degree you entered is out of range, hindi kaya. Then if you input a degree below 3, same response will be yan. And after that, this one is you're going to enter the coefficient of x, the highest degree, based from the input degree. So from the example, it's the x cubed, so we input here 3. Next is enter precision decimal points p. Precision is the number of decimal places shown on the figure. So as you can see, we placed here 4. So the decimal places that was viewed upon finishing the program is 4 decimal places. Here is enter the required accuracy of error. So I set this 0.0001 once x2 minus x1 absolute of x2 minus x1 is satisfied. The iteration will stop and the program will display the value, the last value. This one is where you will going to input the first values of x sub 0 and x sub 1. Note that x sub 0 and x sub 1 must not be equal, and their fx sub 0, fx sub 1 is also not equal. As you can see here, if the values are equal, it will display error values. Values are equal, and it will stop the program. So this is the header of the table result. which is similar to the lectures and videos that we studied. And this is the loop. So x of 0 will be equal to the first x sub 0. Same here. And this is the function, the formula in arriving with the fx sub 0 and fx sub 1. As you can see, this is the formula that we have discussed during the first part of the video. And this is also the same formula to arrive with the f of x of 2. This is the line where the values will be presented upon finishing the formulas indicated here. So for the next iteration, x sub 0 n will be the next x sub 1 of this function, and x sub 1 n x2 will be the x sub 1 n of the next loop until the absolute value of x2 minus x1 is satisfied based from the input value of e. So this will loop until the accuracy of error input is satisfied. So at the end, you will see here that this will calculate the number of iterations done until error was satisfied and the approximate root of x2. And at the end, it will flash thank you for using Secant Method calculator and created by John Patrick San for the Math 221 school year 2022 term 2. And there you have it. I will run again the same program and comparing it again. So this is the program. I'm going to input 3 and coefficient of x cubed, which is 1, coefficient of x squared, negative 4, coefficient of x, 1, coefficient of the constant, 10, negative 10. Positions will be set at 4 and accuracy 0.001. Initial values will be 4 and 5. So again, it was similar in our lectures, which arrive at 5 iterations, and x sub 2 is equal to 4.3069, supported by this formula. Same. Ay, sorry. This bisection, secant method. And that is the end of my video. Thank you so much and God bless.